Hello, students. In this video, we're going to talk about the properties of matter. We know that there's three forms of matter, that solids, liquids, and gases. Now we're going to talk about how those forms of matter can undergo either physical or chemical changes. So one of the things we need to identify is what is a physical property. A physical property is one that doesn't change the composition of the matter. So for example, the color, the texture. Anything with your five senses that can detect it is an example of identifying a physical property. A chemical property is one where you would be able to identify it because it reacts and forms a different type of matter. There's been a change in its composition. So flammable, corrosive. These are examples of chemical properties. So again, with physical properties, the matter doesn't change. Okay, so identifying physical properties, think of metals. They're shiny, they're lustrous, they can conduct heat, electricity, right? When you heat a pan on a stove, it's still the pan, it just gets hot because it's a conductor of heat. These are all examples of physical properties. So, three of the physical properties that are really critical in identifying what the substance is are its melting point, its boiling point, and its density. So we've already discussed density. And we've also discussed that water is kind of used as a reference point for density because it's very simple. It's 1 gram per mil. And just like with melting point and boiling point, I want you to be familiar only with water's melting point and boiling point. So water melts at 100 degrees Celsius. So if I took an ice cube, set it on a table, it's going to start melting, but it's still water. It just goes from a solid to a liquid state. The boiling point of water is 100 degrees Celsius. So here I have liquid water. I add energy to it. The energy separates the water molecules, gives them more kinetic energy, and now they're further apart. And when they're further apart, like we see here, that's when they become a gas. So that's an example of boiling, adding energy to overcome the attractive forces between the liquid particles to separate them, and now they become a gas. So again, water is kind of critical. We want you to know that the density is 1 gram per mil, the melting point is 0 degrees Celsius, the boiling point is 100 degrees Celsius. It's a good reference point for other substances. Water is the only one you need to know these physical properties for. But if you know those three physical properties, you'll be able to identify any unknown. What about chemical properties? So chemical properties are where the substance would actually change its composition. So in this case, we have a nail, right? And it's just composed of iron atoms. You leave it out long enough, it's going to combine with oxygen in the air. And when it combines with the oxygen in the air, right, you end up getting iron 3 oxide. So we can see in this picture, it's no longer just iron. So it has actually changed its composition. That ability to rust is a chemical property. Why? It changes its composition. A reaction occurs. So chemical properties are where the composition will change. So an example is if I took a piece of paper and I lit it on fire, that's changing its composition. That's because the paper is flammable. That's a chemical property. If I combust it or if I burn it, now there's a chemical change, right? If I just take that piece of paper and I squish it in a ball and throw it in the trash can, I've only changed its shape. That's a physical change, not a chemical. It's still a piece of paper. If I take a piece of paper and I rip it, that's still paper. So that's only a physical change, not a chemical. So again, physical changes, it's the same substance. You might have changed its appearance, right? Squishing it in a ball, ripping it, it's still a piece of paper. A chemical change is where you actually change its composition. So me lighting the paper on fire, it's no longer paper. So we express chemical changes by writing out chemical reactions. So we could have word chemical reactions, or we can use molecular formulas, which will be going on in later chapters. But primarily your reactants, your starting materials are on the left, and your products, your ending materials, the materials you produce, are on the right. So in this example, we see that we have butane in our lighter. If I don't ignite the butane, it'll simply escape into a gas phase, and I see that it's still the same substance. The only difference is how far the molecules are from each other. So that's only a physical change, right? It's just further apart. So now the state of matter, instead of a liquid, is a gas. A chemical change is when I actually change its composition. So here I have the butane. If I initiate a spark and it combines with oxygen, the carbon and butane, which are the black dots, combine with the oxygen to produce CO2. And then the hydrogens, the white dots in the butane, combine with the oxygen in the air to produce H2O, right? So we'll get more into balancing chemical reactions, writing chemical reactions, but right now I simply want you to identify a physical change is where it doesn't change its composition. A chemical change, you actually rearrange the atoms and combine them or form new types of matter. And that's what a chemical change is. And we write it out with a reaction. So I hope this video makes sense, and thanks for being patient and tuning in.